Hi, my name is Brad Spearing, and for the next few minutes I'm going to show you how to create trade studies using Flames and automate them using ModelCenter. I'll begin by giving you a brief overview of both Turnitin Corporation and Flames, and then I'll actually create a trade study using Flames and show you how to automate it using ModelCenter. Turnitin was founded back in April of 1989 for the express purpose of developing commercial software products that we could make available to the growing simulation marketplace. We refer to the software that we eventually developed as Flames. Turnitin sells licenses to Flames, and we also provide custom simulation development services to Flames customers for those who want some assistance in building their custom Flames-based simulation. As you might expect, we've got customers all over the world. Flames is what we refer to as a simulation framework. It is actually a framework for object-oriented, composable, component-based simulations. Flames provides, first of all, the infrastructure and support software that almost any type of military or entity-based simulation needs. In addition, it provides a set of base classes from which simulation components can be developed. These classes define the interfaces between the components themselves as well as between the components and Flames. Using those interfaces, you can develop simulation components that can be easily combined and exchanged. You can quickly and easily compose custom simulations that are tailored to address specific simulation requirements. Flames customers find that they can develop the simulations that they need that are tailored to their specific requirements very quickly and, relatively speaking, very inexpensively. Using Flames, you can develop simulations for almost any requirement. Simulations that execute scenarios of almost any size. Simulations that have components that are of almost any resolution and fidelity. And you can develop simulations in practically every modeling and simulation domain. There's been a Flames-based simulation developed over the years in each of these domains. Flames itself is a family of products, and that family begins with a set of ready-to-run, customizable, executable programs. The first of those, and the one that you'll use most often, is a program called Forge. Forge is what you use to define a scenario in Flames. Forge stores all of its data in the Flames scenario database. That data then can be read by Fire to execute the scenario. As Fire is executing, it can write out lots of data to results files. And those results files can be visualized with our scenario visualization program called Flash. Flash can also be executed while the scenario is executing and let you visualize it by communicating directly with Fire. And you can also look at those results files and perform analysis, numerical analysis on those results, and create tabular reports using Flare. During this presentation, I'm going to execute Forge to define a scenario. We'll set up ModelCenter to run the scenario using Fire and analyze the results using Flare, and those results will then be fed back into ModelCenter. In addition to the four main Flames applications, the Flames product line also includes a number of options that allow you to augment the capabilities of Flames to address specialized simulation requirements. There's one set of options for modeling the physical environment and for visualizing scenarios. There's another set of options to support interactive and distributed simulation. A third set of options are what we refer to as the high performance options for running on multiprocessor computers and performing checkpoint restart on your scenarios. A fourth set of options is used to extend Flames' analytical capability. The last option, the enhanced analysis option, is what I will be highlighting in this presentation. We'll be using the enhanced analysis option to set up a trade study in Flames and then automate that trade study with ModelCenter. So let's get started. We'll begin by building a simple scenario using Forge. I already have Forge open, and I've already loaded the majority of the data that I'm going to be using to define my scenario. And this is the way you usually start when you build a scenario in Forge. You'll have your terrain data loaded as well as the parameters for all of the models that are going to be the building blocks when you compose the players in your scenario. That would be parameters for platform models and sensor models, weapon system models, and other types of models, as well as human cognition models that will define the human behavior of your models. Again, all that data is already loaded, and I'm ready to build the specific players in my scenario. In Flames, we call players units, and we're going to be building a scenario with 5 units. This scenario is much simpler than a scenario that you would typically define in Flames, but it's kept simple on purpose so that I can highlight how you would use the Flames Enhanced Analysis option. We're going to define one surface-to-air missile site, SAM site, and 4 enemy aircraft that'll be flying north over the SAM site. And we're going to be defining a parametric study that studies the sensitivity of the number of units killed to the speed and altitude at which the aircraft are flying. So we'll have 2 independent variables, speed and altitude, and 1 dependent variable that we're going to be studying. That's the number of units killed. So let's move on and define our first unit. All I have to do in Forge is right-click on the screen where I want a new unit to be created, select New Unit from the pop-up menu, and I get this window here that lists a bunch of what we call patterns for units. Now you can build units and compose them from scratch if you're an advanced user, but most users will build units this way from unit patterns. These patterns will automatically generate the input data required to define players, and a given pattern can define 1 unit or multiple units. These patterns are part of the scenario. They're defined in user inputs. What you're looking at here is a list of the patterns that we supply with Flames so that you can build demos the moment you install Flames on your computer. But you're not restricted to these patterns. You can define your own patterns in as many different types as you want. I'm going to select a pattern for a SAM site that is capable of selecting his own targets. And when I select the type of unit that I want to create, it prompts me for the input values required for that pattern. This particular pattern only requires the name of the unit. So I'll type finish, and I get a little icon on the screen here for the SAM site that I just created, the surface-to-air missile site that I just created. I'm going to go down here to the bottom of the screen and create another unit, the first of my enemy aircraft. I'll scroll down in my pattern list to a red bomber, select next, type in the name of the unit, which I'm going to call Bomber 1, because I'm going to eventually create 4 bombers. And I'm going to select on the waypoint parameter and click a point on the screen and select finish. So now I have a scenario with just 2 units. Now let's take a look at the definition of this bomber. This is the unit window, the window where you can type in directly the definition of a unit, and we define units in Flames using script. It's generated automatically by the patterns that we invoked just a few moments ago, but it's here to allow you to be able to do advanced things like making the definition of your unit a function of scenario variables, which is what we want to do right now. You can see here that the initial location and the first waypoint specify constant values for speed and altitude. we want to make those values not be constants, but rather be variables. So we're going to go over to the Settings menu and to the Scenario Variables window and define two scenario variables. One is altitude, and another one is speed. Now this part of the window right here allows us to specify values for those variables. And that's one of the ways that you can use the Flames Enhanced Analysis option. You can specify what we call design cases. And for each case, you can specify what values you want your scenario variables to take on. And then you can define the number of runs that you want to execute in the Scenario Executions window. For each run number, specify the case that you'd like to execute and which random number seed you'd like to start with. And then start up the scenario, and Fire will automatically execute the scenario for all your design cases. That is a built-in capability of the Flames Enhanced Analysis option. However, when your parametric studies get real complicated, this window becomes a little bit cumbersome as a window to use to enter all of the values for all those different design cases. Rather than try to make this window more sophisticated, at Turnitin we decided to instead make Flames compatible with ModelCenter, because the guys at Phoenix have already figured out how to build a tool that allows parametric trade studies, complex parametric trade studies, to be automated. When we're using ModelCenter, we don't need to worry about specifying any values for our scenario variables. We can just ignore these values right here. So now that I've have these variables defined, I can go back to the definition of my bomber and substitute a reference for scenario variables in the place where constants are supplied. Now I need to mention that it's possible to override or to set the value of almost any input parameter in the scenario using a scenario variable. I'm just setting something fairly simple, speed and altitude, but you could specify practically anything, the entire composition of a unit, the wingspan or weight of an aircraft, the rules of engagement, anything that you want to study can be specified through a scenario variable. I'm going to reference speed, and I'm going to reference altitude here in the place of the constant value for altitude. And I'm going to use these same variables to specify the speed and altitude for my first waypoint. And now I have the route of my aircraft specified in terms of my scenario variables rather than in terms of constants. Now I'd like to add 3 more bombers to my scenario. And I can do that very easily by copying the bomber that I already have created. To do that, I simply type in a new name for another bomber and select Accept. And that creates another bomber with the exact same definition. And I can drag that bomber's waypoints to the west. And then I can create bomber 3 from bomber 2 in the same way. And I can create bomber 4 from bomber 3. So now I have a scenario with 4 bombers, all flying north straight over the top of a SAM site. Now that we have our Flames scenario defined, we're ready to perform a parametric trade study using that scenario together with ModelCenter. I've closed Forge and I now have ModelCenter open on my desktop. And I've got a blank model ready to add components to it. The first thing I'm going to do is add a component to the model for executing the scenario. To do that, I'm going to use the Flames Execute plugin. These two ModelCenter plugins, Flames Execute and Flames Analyze, are being developed by Turnian Corporation under a Small Business Innovative Research contract from the United States Air Force Research Lab Munitions Directorate. These plugins are expected to be included in version 6.2 of Flames, which is planned to be released sometime in the last half of 2007. Flames version 6.1 can be used with ModelCenter, and you can do all the same things that I'm about to do right now, but it's a little bit easier with these custom plugins. So I'm going to go ahead and show you how you will be able to do it with the custom plugins. So I'll grab the Flames Execute plugin and drag it into the model window. And it wants the name of the scenario that I'm going to be using to perform my parametric trade study. So I will browse to the name of that scenario, select Open. By dragging this plugin into the model window, a new entry is added to the component tree for that same model. If I expand that entry, you'll see that the plugin automatically looked at the scenario that we're going to be using, and it found out which scenario variables were defined in the scenario, and it listed those variables in the component tree. That's one of the nice things about this custom plugin, is it does all that for you automatically. It knows the scenario variables that are part of your scenario. Well, this component again will execute the scenario. We now need to use a component that will analyze the results. And for that, we will use the Flames Analyze component, and we'll just drag that into the model window, select OK. This component is going to be used to execute Flare, which is the Flames post-processor. Flare requires or uses the structured query language to perform queries on output data generated by Fire. And we have Fire already set up to generate a kills file, and we want to tell Flare to perform a query on the data in that kills file. Well, we can do that interactively if we were running Flare standalone, or we can also do it from a query file and let the model plugin run Flare in a batch mode. And I've already have that query file set up. I'm going to browse for that. In fact, before I do that, I'm going to let you just take a quick look at it. This is the text in that query file. It loads one of the output files that is generated by Fire. It then opens its own output file. It performs a query using the structured query language to compute the number of kills that occurred in the scenario. And it names the number of kills, the result that it calculates, units killed. And then it closes the output file. So I had all that set up before I did this demo. So I specify that file as the input file to Flare. And then I have to tell the component where is Flare going to write its output. And as you saw from that file we just opened, the query file, that we're writing the output to a file called flamesanalyze.out. So I know the input file needed for Flare, and I know the output file, so I can select Accept. And you'll notice that a new entry is added to my component tree for the Flames Analyze component, and it automatically went out and looked and saw that we were writing our output data to a variable called units killed. So it automatically pulled that in and listed it underneath the Flames Analyze component. Now, one more thing we need to do, we need to link these two components together so that ModelCenter will know that whenever the values in one component change, that there's a dependency which requires the other component to be executed as well. To support establishing that dependency, these components both use a variable called finished processing. And those variables are defined by the components specifically to allow them to be linked together. All I have to do is drag and draw a line between the two components. Because they're two variables named the same, ModelCenter attempts to automatically establish a link, which is exactly what we want it to do. So we simply say, fine, go ahead and create the link. And so it creates a link between the finished processing output variable of the Flames Execute component and links it to the finished processing input variable of Flames Analyze. Now that I have my model defined, I'm ready to execute it. There are many, many different ways to execute a model using ModelCenter. And if you've tuned into other webcasts or you're familiar with ModelCenter, you've probably seen many of those ways already. I'm going to execute it using two fairly simple ways just to show you that it's really working. One of the easiest ways to execute a model, and simplest ways, is to simply type in values for the input variables in the component tree window and then hit the execute button. So I'm going to type in altitude of 1,000 and a speed of 300 knots. And then I go up to the tool button and hit run. And you can see that the two components lit up briefly, indicating that they were actually being executed. And the number of units killed was 3. I can change the speed to, say, 800 knots and run again. And only 1 unit was killed. So that's one of the simplest ways to execute the model. Another way to execute a model is using the carpet plot tool. This particular tool is designed to be used when you have 2 design variables and you have 1 response variable, 2 input variables and 1 output variable, which happens to be precisely the situation that we have right now. To use this, you select your input variables by dragging them from the component tree into the carpet plot tool window. So I'm going to select altitude and speed and drag them in here. And you select the output variable in the same way. Now what I'm going to do is specify a range of values that I want to be used for each of my design variables. I'm going to allow altitude to vary from 5,000 feet to 10,000 feet. And I'm going to allow speed to vary from 300 knots to 800 knots. And I'm going to accept the default values here for the number of steps. So it'll be a total of 4 values for altitude, a total of 4 values for speed. And all combinations of those will define 16 executions of the model. To execute, I simply select the Run button. And while it's running, you can see that it's creating a table of output values. And you can see things blinking up here in the screen as the components are being executed. And it's executing now 16 runs. So I can look at the results in the output table. I can also look at the results graphically. And there are a couple of default graphs that are already set up by this carpet plot tool, and you can define other graphs yourself. One of the ones is a response surface 3D plot, and this shows altitude and speed in 2 dimensions and units killed going up. And you can see here from this output that the number of units killed is relatively insensitive to the altitudes in the range that I've specified. It's much more sensitive to speed. But the faster that I go, the fewer number of units get killed. So we've just done a simple parametric study using flames and automating it with the carpet plot tool of ModelCenter. If you'd like more information about Turnitin or flames, you can of course contact Turnitin by either phone or email. Our contact information, as well as a lot more information about both Turnitin and flames, is provided on our website, www.turnitin.com. You can also access the Flames forum, where Flames users and developers share ideas. You might also want to consider attending one of the Flames user group meetings or attending a Flames training class.